This is regarding the Oil Express flow cell maintenance. As you run your instrument over time, you will note that the flow cell begins to clog or be fouled with soot and other residues. Sometimes even lint from rags can get in there. And disassembling and cleaning of the flow cell will become necessary. These steps are to show you how to disassemble and clean the flow cell and put it back together properly. So the first thing we need to do is to disconnect it from the dispense cup. So we can remove the dispense cup line or lines by removing the lure lock fitting, twisting counterclockwise to remove it. And once you've done that, you can slide the whole tray assembly back just a little bit to give you better access to the shuttle and the flow cell. At this point, before we turn off the FCM to prepare the shuttle for removal, we want to make sure we power the FCM off to protect the liquid presence sensor from any damage. So we've turned off our FCM, we can unplug our liquid presence sensor, and before we remove the shuttle, we need to make sure that we turn off the Spectrum 2. The right way to do that is by unplugging this power lead. We can see now that this amber LED is flashing. That indicates that it's up and running and it has been initialized. We will just unplug it by simply removing the power lead. And now it's ready to remove the shuttle from the flow cell compartment. So with the FCMs off, we're going to slide the shuttle forward about an inch, and be careful, the front lip of this tray can be rough, and we're just going to slide it forward about an inch, and so that frees the shuttle. At this point, we're going to disconnect the flow cell lines. So we'll raise the arm on the front of the flow cell. Typically this would be captured with an O-ring, but this O-ring is deteriorated, so we're going to leave it there to keep it in place. And this arm will slide back, and there's a ball detent to hold it in place. And then we can lift it out and very carefully remove these fittings from the flow cell. So with your toolkit that you received with the Oil Express, there should be they call it a spanner wrench, typically called an open end wrench. You can grab the two flats of these blue fittings, these blue polymer fittings, but if you have a really good set of duckbill pliers like these, you can also use them. You just want to be careful not to grind away at this blue plastic and ruin that fitting. So we're going to very carefully loosen it just enough so that I can remove it the rest of the way with my fingers. So the lower tubing goes to the dispense cup. So we're going to remove that one and set it aside. Okay? The top fitting goes to the fluid control module, or the FCM. So we're going to remove that one as well. Note on all of these fittings, there is a ferrule. Once this thing has been installed, once the assembly has been installed, this should be crimped onto the line so it doesn't come off. If this is a very new flow cell, this may come off. So just be mindful of that and make sure that these ferrules stay in place when you remove the lines. We're going to set the flow cell aside, and this shuttle can come the rest of the way out like this, and we can sit it up on the FCM. The reason that I demonstrate that is if you have a dual stack spectrometer system like this one, the only way to access the flow cell on the lower spectrometer is to remove the shuttle. Always make sure you turn off the Spectrum 2 before you remove the shuttle, and turn off the FCM. Okay, when you put it back in, that will be the reverse. This is the flow cell that we use with the Oil Express. You can tell that there's a serial number here at the top. There's a number here that represents the path length. This will not necessarily represent the actual path length once we're finished with the reassembly. So one thing to keep in mind while you're handling the flow cell, these are zinc selenide windows, so we have to be very careful with our handling because that zinc selenide material is toxic. We're going to need a few tools to do this. First of all, we're going to need heptane to clean the cell with. if there's any Citrojet residue from Citrojet cleaning, you have to make sure to have water, DI water or distilled water on hand to use that to get the Citrojet residue off, since it is aqueous. Now, we'll also need, I like to use toothpicks, and we'll go over that more later. I've made these alignment pins from the large gem clips. Metric Allen wrenches, I use a set of tweezers to retrieve the components from the heptane as it's cleaned. The torque wrench that came with your kit, that came with the Oil Express, it should be set to 24 centinewtons per meter. And I use a razor knife for removing the gasket off the back of the flow cell very carefully, that we'll describe later on. So the first thing we want to do is to start disassembling the flow cell and cleaning the items. I like to clean the windows first while the heptane is at the cleanest. We're going to use Chem wipes, and you can use just a soft paper towel as well. We just have to be careful not to leave any residue behind, any lint that would grab onto soot as it goes through the flow cell. That's why I do not like to use Q-tips, because the lint from the Q-tip can grab onto parts of the flow cell, zinc selenide windows, and cause issues later. So we're going to start by removing the two small port screws that are on the front of the flow cell. Bear in mind, these have a seal up underneath them. There is an Oil Express zinc selenide windows kit that you will need to have on hand before you attempt this. The reason being is a very, very good chance that you could break one of the zinc selenide windows when you do this, so you will need to have those as a backup, or a spare flow cell is even preferred, is even better. So we've removed those two. I'm going to set all the dirty components off to the side here. I'm going to use my torque wrench, and I'm not going to back out on these screws all at once. You don't want to put any pressure on one part of the windows. You want to spread the pressure evenly when you put it on and take it off. So they're all loose now. We can back them all the way out. Underneath these screws, there should be 3 thrust washers for each one of these screws. We're going to leave them in place. Once we've removed the screws from the top plate, we're going to lift the top plate off gently. We notice we have the ports here and here, and the ports that go into the front of the flow cell here and here. Those will be cleaned later. We're going to use our toothpicks to do that with, to prevent scratching. We have the front gasket. It's thicker than the center gasket, and it's symmetrical, okay? So we'll set it aside as well. We're going to remove our guide plate. Symmetrical, it doesn't really have an orientation. And we're going to remove our top ported zinc selenide window. We see the ports here and the etched paths that the oil will travel through before it goes across the window where it will be scanned. We'll set that aside on a separate location. And we're going to remove the wedge-shaped gasket that goes on the inside of the flow cell. The way you can tell which way this one will go on reassembly is we're going to hold it up to a light, and you will see the top edge can be seen through easier than the bottom edge. So the bottom edge will go to will be the thicker side that will go down during the reassembly. Now this one, you can tell, has been damaged. It's cracked. So that's why it's very important to have the kit, the L1600242 Oil Express 4 zinc selenide flow cell kit, just for this very reason. Now, if this was not broken, we would be very careful in removing this bottom zinc selenide window from the rubber gasket. This one came loose very easily, probably because it was cracked. If not, you can place a razor knife very carefully. You're not going to try to scratch any of the back plate, but you're going to push this in underneath the rubber gasket, and you're going to start to apply a very, very gentle but even pressure, and you will watch a air gap begin to grow on your rubber gasket between the gasket and the zinc selenide window, and you let that increase until that goes all the way far enough and it will lift off. If that doesn't want to work, then you can soak it in heptane for a while before you attempt it, and that will help to prevent breaking of your zinc selenide window. Once again, this is toxic, so we're going to take this and immediately we're going to wrap it up, and we're going to put it aside for proper disposal later. Lastly, we're going to remove our rubber gasket from the back plate. Once again, this one is symmetrical. It has porting that is not really used. We're going to use heptane to clean the components. We're going to start with the components that are most important to keep clean first. This is just heptane, and it helps to have the pure heptane, the N-heptane. We'll put just enough to cover the components. And we're going to start with our zinc solenoid windows. We'll drop them in, and we'll clean them that way. Now, we have new ones from our kit that we're going to use for this installation, so cleaning is not required on those, but I did want to demonstrate how I clean them. So to remove them, you can have tweezers or something to remove that, but you have to be careful not to ever scratch it in the area that's going to go over the scan portion of the window. Very gently lift it. If it needed to be cleaned in the ports, we're going to use this toothpick to clean the ports and the etched pathways. Very gently remove any soot residue. You'll have to look for fibers of cloth. Typically those can get caught in here, and if left behind they will grab soot and cause issues. So we're going to take a clean chem wipe. If you have lens wipe materials, then that's better. And you're going to gently clean those off, and you're going to place the clean windows on a clean chem wipe so that they will be ready for installation. Once you've cleaned the windows, we're going to go back and start cleaning the other components. We're going to clean our gaskets next. So I'm going to move this out of the way. I'm going to get a clean chem wipe. We're going to remove our gasket. We're going to wipe it off. Now bear in mind, if you see any indication that there's something on here that's not being removed with the heptane rinse, you want to make sure to try DI or distilled water in case it is a Citrojet or another material that is aqueous. Okay, the smaller components or the gaskets are cleaned. We'll drop our screws in next, the porting screws. We'll make sure they're clean. The ends of those can collect soot and lint from the oil passing by the ends of the screws. We're going to inspect our seals to make sure that they're not damaged. If you ever take one of these apart and there is oil on the outside of the flow cell, that's an indication that your lines or these seals or the windows themselves were leaking. So you'll have to make sure you check for any place that leakage could occur. So we're looking for the seals to be damaged. If these are over tightened, you will see that they're actually pooched out, if you will, from the side of the screw head, which will allow the oil to escape from behind it. Okay, so we'll clean our guide next. Our back plate. The kit will come with new gaskets, so you can use the new gaskets if you have the kit. If you don't break any windows and you don't need or use the kit, as long as the Teflon gaskets are in good shape, you can put them right back. Bear in mind when you start to assemble it, keep the serial number up so you have everything in the same orientation. We're going to place our guide on. Going to clean our top plate. So this is where I like to use my toothpick to make sure there's nothing left on the face of the front ports, where the ferrule from our blue fittings and the tubing will have to seat. Make sure there's nothing left in the porting. And we'll give it a final rinse. And if you have clean, dry air, you can blow it off gently with clean, dry air in the ports with the top plate, if we don't have compressed air handy, and of course we never want to use oxygen, we're going to use this device that I've found that is just a small blower that can be plugged into a USB port, and we can use that to blow out our porting and dry the heptane before we reassemble. So we're going to collect an empty cell spectrum after we assemble this, so we want to make sure to keep all the extra hydrocarbons out of the assembly. So that's why it's kind of important to dry these areas off that are a little more difficult to get to. Once that's dried, we can start to build our flow cell back. So we're going to start with the gasket, the rubber gasket in the rear or in the back of the assembly. Then we're going to get, in this case, we're going to get our new window, and there will be one that's non-ported and one that's ported from the back. It comes in a very good lens wipe. So you can save those for wiping the zinc selenide off later, but just remember that they've been exposed to zinc selenide, so if you save them, mark them as toxic. So we're going to put our rear window down. You can always check to see how clean it is by looking at the reflection. If you see a speck of anything, you can wipe that off. Okay, so we have the rear one now. Once again, we're going to grab our wedge-shaped spacer. We're going to make sure that the area that we can see through most clearly is at the top. We're going to drop that in with the thicker part at the bottom, serial number to the top. We're going to get our ported window. Carefully remove that. Wipe off our newly cleaned or new window. We're going to drop it in place. Now be careful here with these really clean windows and the new ones. You want to make sure to keep the porting down when you put this back together, or of course you'll have a mess once you start it back up. Okay, so now we have that. We use the top Teflon gasket. Drop that one in place. Every time I'm lifting this spacer up a little bit just to help guide everything and keep it in place. Now we're going to take this top plate and we're going to use our guide pins that we made from the gem clip. One of them is slightly longer than the other one. And here it helps to be able to get down sort of eye level with the assembly. We're going to drop the long one in the space that's away from us. And bear in mind, the flow cell is going to go with a porch to the left, and the longer piece that sticks out is going to be to the left as well. I'm going to carefully insert the rear longer guide pin through the top of the gasket into the zinc selenide port. And then I'm going to follow up and carefully do the same thing with the other window. And as mentioned before, it really helps to be able to get to eye level to be able to do that. So once we feel confident that our gaskets are lined up properly and the guide pins are in place all the way through the stack, then we can begin to install the screws. So it may help to use the Torx bit to drop them in the hole while you hold the washers in place. And if it shifts a little bit, it's not a big deal because we're going to use our guide pins to align things right before we start to tighten the stack. Okay, so we're just going to, by hand, gently move these down. And before I make contact with the top plate with the screws, I like to make sure that everything is very close, but not quite touching. So we touch it off and back it off a little bit. And then we're going to make sure that we're centered by just rotating these around a little bit to make sure they center everything. And then we're going to touch off the center screws first, just a little bit at a time. Touch off the outside next. Go ahead and grab our torque driver. We're going to do it just a little bit at a time. Going to compress the rear rubber gasket evenly, just a little at a time. Okay, now we can remove our guide pins. We can put our port screws back in. And here we don't have a torque wrench typically, but you're just going to gradually move it in a little bit until it feels snug and you feel like you've compressed that Teflon seal without deforming it too much. Just enough to make the seal. So we've assembled our flow cell now properly, so now it's time to put this back into the Spectrum 2. Now that we have our flow cell reassembled, we're going to put the lower line in first, and we must be careful not to cross thread this fitting. If you start this blue fitting and there's any resistance at all, then you need to start over and make sure that you're starting it straight and correctly. If not, then you're going to wind up with the threads crossed, and you can force it all the way in, but there's no way to ever know that it's tight. So once we finger tighten it, you're going to notice there's a preform to this tube. Now this is important. We don't want this influencing the dispense cup and pushing against it, so we're going to have this down in the position that it goes in, and we know we're going to have to tighten this about a quarter turn more, so I'm going to start it right about here. I'm going to get it finger tight. I'm going to make sure that my tubing is pushed all the way forward so that it's all the way through the ferrule. I'm going to grab my end wrench, or in this case my pliers, and very carefully grabbing the flats, not letting it twist on the plastic. I'm going to turn it another quarter of a turn after finger tight. You'll feel it snug up. Then we're going to repeat that for the line that goes to the FCM manifold. Once again, being very careful not to cross thread it. And actually that one was trying to start incorrectly, so I made sure that we started it back correctly. Once again, make sure the tube is all the way in. Ferrule is still in place. Another quarter of a turn. And that is ready to go back into our shuttle. We're going to grab our shuttle. We can rest this somewhere. The zinc selenide flow cell is up inside there. These are the clean tips. So we're going to put them there. I'm going to drop this in an inch or so back from its final position, and we're just going to snap it back into place. Okay? So now we're going to slide our flow cell back into the location where it goes. Let it make sure it slides in easily, bottoms all the way out. We have our serial number to the top. We have our initial path length, which we will change later, showing at the lower part of the front plate. We're going to gently push these into the recesses and the clamp assembly. We're going to make sure that we push it back into the flow cell liquid presence sensor here without any sharp devices. If you use something to help push that in, make sure it's something that's not going to damage your liquid presence sensor. And then we're going to tighten up the thumb screw on the clamp. Make sure our arm is back in the front position on that spring-loaded detent. Our liquid presence sensor is still plugged into the FCM, so we can turn the FCM back on now. Switch is in the rear of the FCM. So we're going to make sure that our wires and tubes are routed properly. We're going to slide the stack or the spectrometer back to its position. And the lower spectrometer goes to dispense station number 1. We're going to make sure that lure lock fitting is pushed forward and sealed. And the upper spectrometer goes to dispense station number 2. You see I'm supporting the dispense cup as I'm inserting this. Okay, so that's inserted. Our FCM is back on. Now we're going to plug the power back into the Spectrum 2. Now when the Spectrum 2 first starts, There's an amber light beside the power receptacle, and it will glow a steady amber color. After it's initialized, it will begin to flash. During the initialization, we should see the shuttle move in and out. So that takes a few minutes to happen. After we've replaced our flow cell and all the lines are connected back up and the FCM is back on, we want to do a quick check to see how well we align the gaskets on the flow cell. We're going to do that by opening File Explorer on our computer. We're going to go to C drive. We're going to go to Program Files or Program Files 86 on a Win 10 system or 64-bit system. We're going to go to PerkinElmer. We're going to go to Service IR, and then we're going to go to Fluid Control Module Test. We're going to select the upper or lower, in this case the upper spectrometer, or excuse me, the upper FCM, and we're going to select Connect. Once the connection is established, we want to be careful at this section. We never want to let this negative number go greater than negative 600, or it could cause internal damage to the FCM. This tool can be useful for troubleshooting your FCM and to find out if there are any obstructions in the tubing or the flow cell itself. There are a set of tests that you can run to test your FCM, and you will need the line that comes with your OE4 kit, but we're not going to do that for this exercise. All we're going to do is open valve 1, make sure it responds and you hear a clicking sound on the FCM. Then we're going to turn on the pump. Be ready to turn the pump back off. But we expect to see this number between a negative 100 and a negative 130 if all is aligned well and there are no obstructions. Now, you just saw what would happen if you obstruct the dispense cup by placing your finger over the top of it. So if you leave it there, it should settle back down to near negative 100. So we feel pretty good that we've aligned our gaskets properly within the flow cell when we reassembled it. So when you turn it off, you want to make sure to turn the pump off first, let the pressure bleed down, and then go back and turn the valve off, disconnect, and close the fluid control module utility.